Okay,
This isn't
so on this
actually the
next
same,
lab,
but that's fine.
anybody know what the reference is on the title?
Hold on, let me read it. No.
Wait, I know that song. I can't remember what it's called right now. Wait.
It is a song.
Yes, I can see clearly how the rain is going.
Yes, winner, winner, chicken dinner. Okay? So, now, if there was ever a lab
Are you
that
setting
you
values?
follow the spirit how of this lab is written, okay? So,
Just a few decimals.
especially on this concept, what they found related to brightness of bulbs is that you tend to have certain misconceptions about which bulb is going to be brighter, which bulb is going to be dimmer. And what they found is that even if kids do calculations and they actually use these with actual bulbs, and bulbs themselves kind of get a little bit wonky, but especially like those cheaper ones, and like they should have the same brightness, but one kid thinks, oh, this one should be brighter. And if they build it and it's actually looks brighter even though it shouldn't, all it does is like reinforce that idea, and literally like no matter how you tell them, it's like, no, I know it looks brighter, but in reality they're the same, and you try and prove it mathematically, they still hold on to that concept. Okay? So this is why this lab especially, why we're going to use the FET simulation, because the brightness is very much reflective of that power. Like if they're the same power, they are going to look the same brightness. So let me explain the spirit of how I wrote this lab. So if you turn over to page 2, you've got these different clusters of bulbs. So let me explain what I want. So like over here on this first one, boom, 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 and then you've got like a low, and then you've got a low, and then you've got connected back. And then over here I've got P, and then I have A. So listen to me, okay? The P and the A are not power and amperages, okay? The P and the A are predicted and actual, okay? So on all of these bulbs, when you see P on a line and A on a line, it is not power, it is not amperage. It is what is predicted and the actual result. So here's the spirit of this lab, is that you're going to look at this and you're going to have this circuit, okay? And we're using the traditional version of the electricity. It's the positive charges that are moving, okay? So this electricity is coming around like this. We're going to use the Ben Franklin version of this lab. So if you think, let's just say hypothetically, you think this first bulb should be brighter than the second bulb. That's what you think, okay? And the predictions aren't right or wrong, okay? They're just predictions. So you think, I think that first bulb, because it's getting the electricity first, should be brighter than the second bulb. So you would write 1 and 2. So your prediction is that the first bulb is going to be brighter than the second bulb. Okay, that's your prediction. It isn't right, it isn't wrong, it's just a prediction. Then, the idea being is that then you actually build it in the circuit builder. And then you look at it and go, in reality, in actuality, what was it? Okay? Were they both the same? Was the second one actually brighter than the first one? If they were the same brightness, you're just going to put 1 and 1. If the second one is actually brighter, you would put 2 and 1. If it actually goes like you had predicted, you're going to write 1 and 2. Okay? So listen to me. This is not power and amperage. If I want an amperage, I'd put I anyway. Okay? It's predicted and actual. Okay? Now, on cluster number 1, there's a second one over here, where you have the high and then a high one over here. These are completely separate entities. In other words, I don't want you to compare the brightness on the low ohmic bulbs to the brightness of the high ohmic bulbs. You are not comparing them side by side. The comparisons are only within the cluster itself, okay? So don't guess and go, oh, the low side should be less bright than the high. That's not what you're comparing. You're comparing low to low, you're comparing high to high. You're not comparing them side by side. It is only within the circuit itself. Does that make sense? Okay? No ambiguity. And again, these are predictions. That's the beauty of it. And if you build it and you're wrong and your prediction was wrong, hey, cool. Great. Welcome to science. Okay? Now, on the front of the lab, I lay out the parameters of what you've got. So, all high resistance bulbs. So when you build this, you're going to have to change the resistance of the bulbs. Your high resistance bulbs are 40, your low resistance bulbs are 10, and the batteries are 20 volts. So that has to be set if you want to verify the calculations later on. Okay? So I built this, and I built this answer key around those assumptions. That you're using 40s on the highs, 10s on the lows, and you've got a 20-volt battery. Okay? Now, again, I say this in the instructions, but you are horrible at reading instructions.
No.
So, on cluster number 1, okay, and I'm referring to cluster number 1 as this whole thing over here, what you want to calculate is the current going through the low, because of the fact that it doesn't make any difference which one you pick because they're both low. So you're going to have the current going through the low, and then you're going to have the current going, or the power in the low, and then you're going to have the current in the high and the power in the high. So there's no difference between them because of the fact that the lows are the lows and the highs are the highs. When you get to cluster number 2, you want to calculate the current in the low side. Why is the current the same even though the bulbs have been reversed? So when you're looking to answer that question, think that through. When you get to question number, or cluster number 5, cluster number 5 is the most complicated one. So if you look on cluster number 5, I've got 2 low bulbs, low bulb A and low bulb B. That's what that's standing for. So if you look at that diagram, that's what that LA and LB are standing for. There's 2 different low volt or low resistance bulbs in that circuit. That's why there's LA and that's why there's LB. Okay? All right. On all of these, again, same parameters. I want 2 decimal places to the right of any calculated value. Sydney, okay? I'm just telling you now. So, oh, I forgot. I'm telling you now. I want 2 values to the right. I don't care. Okay, so just get a good start on this. We'll finish this up on Monday. Again, you do not just do this, just to slam through it. Use this to think through, to make predictions, to see what happens, okay? So get as far as you can. I know it's prom weekend going into it. That way you don't have any homework over the weekend to worry about, okay? All right, Danny.
Like we space